and we're gonna go straight. So we have one that's okay. So we're going slow guy, slow, and the faster guy. Create a table. RTD. The slow guy is traveling at 20 miles an hour. The faster guy is traveling at 30 miles an hour. They're going in opposite directions, and time-wise, we don't know. So we want to know how long will it take for them to be 300 miles away from each other. So distance will be 20t here. This will be 30t. So it's saying that when will the distance of the slow guy plus the distance of the faster guy equals 300. This one, pretty simple. So it's 50t equals 300. We're going to divide both sides by 50. T equals 6 hours. So in 6 hours, so if you go back here, and we know the time is 6, and you multiply, so let's go to the distance. If you multiply 20 times t, we're going to get 120. If you multiply 30 times t, which is 6, you're going to get 180, right? So in 6 hours, the slow guy will travel 120 miles, and the faster guy will travel 180 miles. So think about it. So one guy is going this way. He's going to be traveling, after 6 hours, he would have traveled 120. The other guy is going this way, and he would have traveled 180 miles. So after 6 hours, you say stop. Right? One guy is here, the other guy is there, and you measure that distance, and the distance would be 300 miles. So that looks good. 21. Motorboat leaves the harbor and travels at an average speed of 18 to an island. So here's a boat going to the island. Here's the island, right? Waves. And going to the island. Okay, so we got going to the island and then coming back from the island. That's the trip that he's going to take. So going to the island, he's going at 18 miles an hour. The return trip was 12, so he's going maybe against the current. We know the total trip took 5 hours, so we don't know how long out of the 5 hours it was the going part and how long of the 5 hours the coming back part. So if we call this t, and we know that the total amount was 5, the coming back obviously will be 5 minus t. Then the distance part, right? The distance is obviously the easiest part, so just going to multiply. And this is going to be 60 minus 12t. What do we know about the distance going and the distance coming back? Well, it's the same distance, right? So the distance going equals the distance coming back. We're going to add 12t to both sides. Plus, this is going to be 30t. Those are going to go away, and we get 60 here. So divide both sides by 30. T equals 2 hours. So going, it took 2 hours, because t equals 2. And coming back, 5 minus 2. Coming back, it took 3 hours. It makes sense, right? Because going, the speed was faster. 23. Jet plane overtakes a propeller plane. So we have a jet plane. Why do this looks so familiar? The propeller plane drives planes traveling 190 miles. How far from the starting point does the jet overtake the propeller-driven airplane? So two planes were flying. Obviously, the smaller. So we got the fast plane, and then we put the slow on top. All right, so the slower plane, the propeller plane, took off. It's in the air, and it's traveling at 190 miles an hour. The faster plane is traveling at 570 miles an hour. So the slower plane takes off. He's in the air 2 hours, and then the faster plane takes off. So this guy is in the air for t plus 2. The faster plane is only in the air for t. And we want the distance, right? How far from the starting point did the faster plane take? So what was the distance that they traveled? So what do you call it? Multiply. We get 570t. Here we're going to get 190t plus 380. So what do we know? So here's the slow plane. Here is the fast plane. So the slow plane took off, right? The faster plane waited for 2 hours and then takes off, right? And then obviously the slow plane keeps going. at some point the fast plane catches up to the slow plane. What is this distance, right? That's what we're looking for. So what do we know about both distance? We know that both of the distance are the same when the airplanes catch up to each other. Minus 190 t minus 190 t. That goes away. 380 comes down. And let's see, 0 and 0. 17 is 8. 4 minus 1 is 380. Divide both sides by 380. And then t equals 1 hour. It took 1 hour. It took 1 hour for the faster plane to catch up to the slow plane. And 507, we want the distance, right? 570 times 1, it means that it took 570 miles for the faster plane to catch up with the slower plane. All right, so far so good. 25. Okay. As part of a flight training, a student pilot was required to fly to an airport and then return. The average speed on the way to the airport was 100 and the average speed returning was 150. Find the distance between the two to the airport. Okay, did I do this yesterday? How far? Okay, let me just go back to yesterday's. Motorboat, okay, a jet plane, okay, so the familiar questions. All right, so yeah, okay, so it's not. So 25, so it's very similar questions to the ones yesterday. Part of the flying train, okay, flight training. So here is the origin. He's going to an airport, right? Airport. So he has to go to the airport and then come back. So again, we have two parts of this trip: the going and the coming back. So going to the airport. Sorry, 25. Going to the airport was 100 miles an hour. Coming back was 150 miles an hour. The total flight coming back was 5 hours. So again, we don't know how much of the 5 hours was going or how much of the 5 hours coming back. So we call this t. Or you could have called the other one t. Doesn't matter. So one of them is going to be t. The other one is going to be 5 minus t. And that's it. Now you multiply, you get 100t. Over here, you're going to get 750 minus 5t. Sorry, 750 minus 150t. And again, now what do we know about their two distances? Well, the distance going and the distance coming is the same. So our equation is going to be the distance going equals the distance coming back. What is it, 150t? Plus 150 on both sides, right? Because we have variables on both sides. That goes away. That makes it 250t equals 750. We divide both sides by 250. And t equals 3 hours. So, but the question says find the distance. So, although we found the time, so t equals 3 hours here, and then t equals 3 hours here, which makes the coming back portion 2 hours. So, going to the distance column, all you got to multiply is 100. Was flying at 100 miles an hour. You multiply that by 3, 300 miles. So whether you use the first one or the bottom one, you get 300 on both. So the distance from here, the origin to the airport, is 300 miles. 27. Two small planes start from the same point of flying. So there are two planes, one going this way, one going that way. Okay, so again, faster and slower. Let's call this the faster and the slower airplane. The first plane is flying 25 miles slower than the second plane. So one is the fast. So if the slower one, so this one is the slower one, right? Which means the fast one is, I don't know why I put X. All right, so the slower one. The first plane is flying 25 miles per hour slower than the second plane. So if this is R, this is the slower one, is R minus 25. In 2 hours, they are 430 miles apart, so we know both of them flew for 2 hours. So this is 2r, and this becomes 2r minus 50. What do I know about their distances? I know that in 2 hours, when I say stop and we measure this distance to this point to this point, the distance is 430 miles. So I know that the distance of the faster airplane flew, plus the distance that the slower airplane flew, added together gives you 430, and that's your equation. So we get 4r minus 50 equals 430. We do plus 50 on both sides, and 4r equals 480. Divide by 4, divide by 4. R equals, let's see, 120. So the faster airplane was, was flying at 120 miles an hour, and the slower airplane was going at 95 miles an hour, because 120 minus 25 is 95. And there's your two answers. Okay, so far so good. 29. Again, we have a bus overtakes a car traveling at 45, so we have a bus. Okay, then we have a car. So again, RTD, the car started first, right? Started driving for a full hour before the bus started, and then the bus started to catch up, right? And then it took a little bit to catch up, and then at some point they are at the same distance. So the bus is traveling at 60. The car is driving at 45. The car had a 1 hour head start, so the car is t plus 1. The bus is just t. So this becomes 60t. This becomes 45t plus 45. What do we know about both distances? Well, after they catch up, right, they're side to side. The distance that the bus travel is equal to the distance that the car travel. And that's your equation. Minus 45t on both sides. Right? Remember, there's a wall. I keep forgetting that. So that goes away. 15t is what's left over, equals 45. Divide both sides by 15. T equals 3 hours. So the bus took 3 hours to overtake the cars. Is that the question? How long? Yeah. How far from the starting point? So it takes 3 hours. The bus was driving at 60 miles an hour. So 60 miles times 3 hours means that the bus had to drive for 180 miles before catching up to the car. 31. A truck leaves the depot at 11 a.m. and travels at 45. Okay, so let me write that. Truck RTD. So we have a truck here, and he's traveling at 45 miles an hour. Then we have a van, leaves the same place and travels at 65 miles an hour. So, but the van leaves at noon, so that means the truck had a 1 hour head start. What time does the van overtake the truck? So the truck left at 11 a.m., so the truck actually had t plus 1, 1 hour head start because the van started an hour later. So the van is t. Okay. Distance one is, what do you call, 45t plus 45, and this is 65t. So again, when the van catches up to the truck, the distances are the same, so we can write 45t plus 45 equals 65t. So minus 45t, that goes away. We get 45 equals 20t. By both sides by 20. And t equals, let's see, so 2 1/4 of an hour, or 2 hours and 15 minutes. So the bus left, what's the question? At 2:15. Okay, so the bus, so 2 1/4. 2:15. What do you call it? 2:15 p.m. The van overtakes the truck. Okay. 31. We're on 33. 3 campers left their campsites by canoe and paddled downstream. Then they turn around and paddle back upstream. All right, so let's call this downstream and upstream. So I think it's yesterday's questions, right? Just a little bit reinforcement on yesterday's questions, or the different types of questions. So downstream was 10 miles an hour. Upstream was 5 miles an hour because it's probably against the current. How long did it take the campers to canoe downstream? It took total trip 1 hour. So again, here's the campsite. They went downstream, then they turned around and went upstream. This whole trip took an hour. We don't know from the hour how much of it was downstream or how much of it was upstream. So we call this t, and this is going to be 1 minus t. Right? 10t, 5 minus 5t. And what do we know about the distance going downstream and then coming upstream? Well, it's the same. So 10t equals 5 minus 5t. Add 5t to both sides because that's the inverse operation. So 5t. And we get 15t equals 5. And t equals, divide both sides by 15. T equals 1/3, or 1/3 of an hour. So downstream we took 1/3 of an hour, or 20 minutes, which means 1 minus 1/3 is 2/3, and that is 40 minutes. So your answer going to be in terms of an hour, which is 1/3. So t is 1/3, or t is 20 minutes. It's up to you. Do we have an option here? How long did it take the campers to canoe downstream? So 1/3 of an hour, or 20 minutes. Okay. 35. It's not that bad. Walks and jogs. So walks and jogs are 2 categories. RTD. Walks and jogs. Okay. The student averages 5 kilometers an hour walking. So we're going to write 5 over here, and 9 kilometers an hour jogging. The distance from the home to the college is 8 kilometers, and the student makes the trip in 1 hour. And again, so he walks that way and then he jogs this way, right? We know the distance is the same. How far does the student jog? So I don't know how much of the 1 hour was spent walking or how much of the 1 hour was spent jogging. So let's call this t, and obviously this is going to be 1 minus t. So the distance right now is represented by 5t, and the distance that he jogs is represented by 9 minus 9t. Okay. It says the distance from the home to college is 8 kilometers. Okay, so hang on a second. The distance from home to college is 8 kilometers. So here's your home. Here's your college. And the distance is 8 kilometers. Interesting. Hang on a second. How far does a student jog? Wait a second. Oh, I see. I read the question wrong. So sorry, I apologize. So here's home, here's college, right? The total distance is 8 kilometers. So part of that trip he spends walking, and part of that trip he spent jogging. Okay, now I understand the question, right? So I don't know how much of that trip is walking and how much of that trip is jogging. That's what we're trying to figure out. So what do I know about the distance that he walks combined with the distance that he jogs? Well, the distance that he walks plus the distance that he jogs equals 8 kilometers. Combine like terms, we get negative 4t. plus 9 equals 8. We're going to do minus 9 here. Minus 9, get rid of the constant. That goes away. Negative 4t is negative 1. We're going to divide both sides by negative 4. And t is 1/4 of an hour. So he walks 1/4 of an hour, or 15 minutes, which means 1 minus 1/4, he spent 3/4 of that time jogging. So what's the question? How far does the student jog? To find out how far the student jog, we actually have to, you can substitute over here, right? So we get 9 minus 9, and he spent 3/4 of the time jogging. So that equals 9 minus, 27 over 4, which I'm going to just change that to an improper fraction. So that's 9 and 6. And 3/4. Which it leaves us with 2 and 1/4. So he spends that much time, that much distance jogging. What is this? 30, let me just double check. 35. Yep, that's correct. Okay. And we have one more, 37. I think. On a 220-mile trip, a car travels an average of 50 speed and then reduces average speed to 35. So again, same question as prior. We have a trip from here to here, and the distance is 220 miles. Part of that trip was at 50 miles an hour, and part of the trip, because it was local, he drove at 35 miles an hour. So how long did the car travel at each speed? All right, not a big deal. So the faster part of the trip and the slower part of the trip. RTD, the faster part is 50, the slow part is driving at 35. They tell us what the total trip took 5 hours, so again, we don't know how much of the trip was spent driving at 50 or how much of the trip he spent driving at slower speed. So let's call this t and let's call this 5 minus t. Distance is 50t over here, and this is going to be 165 minus 35t. Okay. So what do I know about their distances? Well, if I add the distance that he drove at 50 miles an hour plus the distance that he drove at 35 miles an hour, that's going to give us 220. Combine like terms, we get 15t plus 165 equals 220. Subtract 165 from both sides. Right, remember there's a wall here. And that's going to give us 45. Sorry, not 45. Apologies. 55? One second. 15t. 2055. What is wrong here? 5 times 5, 25. This is 175. I apologize, not 165. So 175. Erase that. Let me erase that. Let me erase that. There was my mistake. So it's when I did this treaty prop, it should have been 35 times 5, which is 175. Okay. So when you combine 50 minus 35, you get 15t, and then this is 175. So I'm going to subtract 175 from both sides. So this should be a 7. That gives you 45. 15t comes down because these two become 0. Divide both sides by 15. T equals 3. So he actually spent 3 hours driving at 50 miles an hour, which means he spent 2 hours driving at 35 miles an hour. All right. Hopefully this is what you were supposed to do.